So in this segment on fractions, we're going to be continuing with talking about the meanings of fractions. We're going to also talk about the meanings of the symbol of the fraction, and we're going to get to introducing a little bit about comparing fractions now that we understand the meaning and the symbol that we're going to use for fractions. Hopefully we'll get to talking about numerators and denominators, and we might even get to equivalent fractions if we have time. In the introduction to fractions, I talked about the 5 meanings of fractions, and the 2 that we're going to be working with primarily in this segment is the part of the whole and the idea of it being divided. And not only dividing, but dividing into equal size pieces. So when we talk about division of something, we want to make sure the student understands that we're talking about into equal size pieces. Very young children might take a look at that, calling it a whole, and then when they go to divide it, they do something like this, and they say they've divided it into half because we have 2 pieces, and so it must be cut into half. And young children will often say something along that line, and we have to make sure that they understand that when we divide it into pieces, we have to be talking about equal size pieces. There are many manipulatives we can use. We can use the circle fraction tiles like we have here. We can use the hexagon pattern block style. We can use Cuisenaire rods. We could use fraction strips, but I'm going to be working primarily with a fraction circle for this segment and a little bit about the pattern block in the hexagon shape. So I'm going to start off with our circle here, and we're going to cut it in half into two equal size pieces. And over here on my hexagon, I'm going to cut that into 2 even sized pieces, and I'm going to have 2 pieces. I'm going to write down the symbol here, and then we're going to talk about what meanings that might have. So within the part of whole meaning of a fraction, there's different ways of looking at this. So I've got my circle, and I've cut it into half. I've got my pattern block, my hexagon, I've cut it into half. Students recognize this 1/2 symbol. They definitely recognize the phrase 1/2. We've talked about having to make sure that they're dividing into equal size pieces. But even with this symbol and with this piece of 1/2, I want to talk about some options here. So this 1/2 is made up of a numerator, and it's made up of a denominator. And there's a couple different ways that we can look at what those words mean. So this 1 on the top could mean I have 1 circle. And the number on the bottom says I've cut it into 2 equal size pieces. Over here I've got 1 hexagon, and I've divided it into 2 equal size pieces. So the number on the top tells me how many whole pieces, how many whole circles or whole hexagons do I start with, and the second number, the bottom number, the denominator, tells me how many pieces I'm cutting it into. And when I say it's cutting it into, I'm actually dividing it. So again, here's our opportunity now to talk about this line that's underneath the 1 and the 2 could actually mean the division symbol, because I'm dividing it into 2 equal size pieces. So again, this is our opportunity to reinforce the idea that we have a fraction means division. The most common way people talk about it is if we have a circle and we have 2 shaded regions. The shaded region I'm going to talk about here is the blue shaded, so I have 1 shaded out of a possibility of 2 pieces. Or in the hexagon, I have 1 red out of a possible 2 trapezoid pieces. So I have 1 out of 2. I have 1 shaded in of the 2 pieces. And that's the most common way of thinking of parts of the whole. The third way that we can look at it, and I think is very useful, and it's not a very common way of looking at it, is I have 1 piece here that's blue out of pieces that I'm going to call them size 2. So I've cut this into 2 pieces, and I'm going to call these size 2 pieces. I've got my hexagon, and I've got 1 red out of a possibility of size 2 pieces. And I'll be coming back to that size 2 concept in a second. So if I take my whole and I cut it up into pieces that look like this, what would I call those pieces? So we can take a look. I have 1 whole circle, and I've cut it into 1, 2, 3 of these. So I'm going to call that each one of those pieces 1/3. I've got my one whole and I divided it into 3 equal sized pieces. I could take this one piece right here and just shade it in a different color. And now I can say I have 1 brown out of 3. So I've got 1 out of 3, or I could say I have 1 shaded piece of, and each of these are size 3 pieces. I can continue and divide my circle up into this, and we'll notice most students recognize this one. This is a quarter, so we can write that as a symbol. So I have one circle and I divided it into 4 different pieces, and I could think of it as I have one yellow shaded region out of 4 possible regions, or I could say I have one yellow region of size 4. I can continue with this shape here and notice that it takes 5 of those, so I could call that 1/5. I could take this color here and it's going to take 6 of those. I can take this color here and it's going to take 7 of those wedges to fill up the circle, and I can take this piece here and I notice it's going to take 8 of those pieces to fill up the circle. And I can write them all like that. We can do the same thing over here with our hexagon. We've got 1 out of 2. We can take this shape and notice that we have 1, 2, 3 of those, so we call that our 1/3 shape, and we can take this triangle down here and notice that we can make that, and it's going to take 6 of those, so we can say 1 out of a possible 6, so we can call that the 1/6 shape. It gets a little bit more difficult showing some of these other ones, and we can rename our 1 into something like this to be able to get to those, but we'll do that at a different time. A very common misunderstanding for students is they know that 8 is bigger than 2. So a common answer is 1/8 is bigger than 1/2 because 8 is bigger than 2. And what we have to do, we have to make sure that our students understand that that's not correct. And so what I'm going to do is I'm going to put the 2 side by each, and we're going to model this. So if I have one circle, my 1, and I divide it into 2 pieces, each piece is going to be called 1/2, and my 1 divided by 2, or my 1/2, or my 1 piece of size 2 is going to look like this. Over here on this one, if I take my 1 circle and I divide it into 8 different pieces, each piece is going to look like one of these. So I've got 1 whole divided into 8 of these green sections, and any one section would be called 1/8. And it doesn't take kids too long to figure out that the blue one is way bigger than the green one. So if we keep showing these in different combinations, we can talk about 1/3 compared to 1/8. We can talk about 1/5 compared to 1/6. Either way, you're going to be able to see that if this is 5ths and this is 6ths, this one's smaller. The bigger the number on the bottom, the smaller the pieces, and that makes sense. If I have 1 pie or 1 cookie or 1 pizza or 1 chocolate bar and I divide it amongst 2 people evenly, each piece is going to be called 1/2 and you're going to get a fair amount of chocolate bar. But if I have to take that same pie or pizza or whatever it is and I divide it amongst 8 friends, each person's going to get a much smaller piece. So yes, the number on the bottom is a bigger number, but that means that the size of my piece is smaller. And we want to spend quite a bit of time making sure that students understand that concept. Again, that just reinforces that this line between the 1 and the 8, or between the 1 and the 2, is talking about dividing. I'm dividing my whole into different numbers of pieces, and therefore it's going to cause a change to their size. What happens if we have a different numerator, different number on the top? So we just put our words in there again. So this 2/3 can again be thinking of 2 different ways, or a few different ways. So one way we can look at it is this 2 means I must have 2 circles now. If 1/3 meant I have 1 circle divided into 3 pieces, this must mean I have 2 circles divided into 3 pieces. And this is not a very common way of thinking about it, but it certainly does work. I could end up something like this. I've got my 2 circles, each of them cutting into 3 pieces, equal size pieces. And if I have 2 of those, and I have 2 there, and I have 2 there, each of those segments, my 2 circles, cut into 3 pieces. Each of my 3 pieces, piece number 1, piece number 2, and my orange piece number 3, what would you call each of those pieces? Well, the 2 oranges would be called 2/3, the 2 greens would be called 2/3, and the 2 purples would be called 2/3. So I could think of it as 2 circles, each of them cut into 3 pieces. What would I call the pieces? The more common way of doing it, I've got 1 circle. The 3 tells me that I've cut it into 3 pieces, and I've got 2 shaded that are orange, and therefore I could call this 2/3 of my circle. That's another way, the more common way of thinking about it. And I could say I've got 2 oranges of size 3. So we could have it as 2 circles cut into 3 pieces. We could think of it as we have our circle. I have 2 shaded out of the 3 totals, so 2 out of 3, 2/3. Or I could say that I have 2 shaded of size 3. All 3 meanings all make sense. They all have their applications. And when we go to talk about comparing the size of a fraction, I think we'll find that I have 2 shaded of size 3 makes more sense to students than saying I have 2 is the number that I have shaded, and 3 is the number of pieces. Now I've got number and number in both questions. So if I say 2 is the number that I have shaded, and 3 is the size that I've divided it into, so I'll have size 3 because I've divided it into 3 pieces. I think we'll find that makes a little bit more sense when we go to do comparing in our next segment.